Let us discuss about the parametric equations of the hyperbola. So, consider the x-axis, the y-axis, and say this is the hyperbola that we have. Now, this point here, we mark it as C, and this is called the center of the hyperbola. And we know, students, that the equation of hyperbola is given by x square by a square minus y square by b square equals to 1, where this point here is a and this point here is a dash. The coordinates are a comma 0 and minus a comma 0. So if we take C as the center and this distance a as the radius and we make a circle, so we make a circle taking C as the center and a as the radius. So this circle here is called auxiliary circle. Auxiliary circle is the circle with center as C and radius equal to A. So this is called auxiliary circle and its equation can be written as x square plus y square equals to A square. Now, in order to understand the parametric equations of hyperbola, what we do is consider a point Q on the circle, and let us say the line CQ is making an angle theta with the x-axis. Now, we drop a tangent at point Q in this particular manner, and this tangent intersects the x-axis at point say N. And if we draw a perpendicular to x-axis from point N, this line intersects the hyperbola at a point we call it as, let us say, P. So this is a point which we take on the hyperbola. Now we have to find the coordinates of point P. So look at triangle CQN. So this is the triangle CQN and this distance here is A. So if we want to find the length CN, we can write cos theta is equals to A upon CN, and Cn is equals to A by cos theta, and that is equal to A sec theta. And therefore, the point P will have coordinates represented by, let us say, A sec theta comma K. So that is how we select the coordinates of point P. Now, P and N basically will have the same x coordinate, and that is why we have taken the coordinates of point P in this manner. Now, since this point P lies on the hyperbola, it must satisfy the equation. So therefore, if we put the equation here and the point in this equation, so what do we get? We get sec squared theta minus k squared by b squared equals to 1, and this gives us k squared by b square is equals to sec squared theta minus 1, and that is equals to tan squared theta. And if we take square root on both sides, we get k is equals to b tan theta. And therefore, the coordinates of point P comes out to be a sec theta comma b tan theta. So this, my dear students, is the parametric coordinates of a point. And if we write x is equals to a sec theta and y is equals to b tan theta, this is called the parametric equation of hyperbola. This here is called parametric coordinates. Now, there is an important thing that we must try and understand. So, since the point is A sec theta comma B tan theta, if suppose theta lies in the first quadrant. So, if theta lies in the first quadrant, the point, so let me write in the following manner. We are taking theta here and the location of point P here. So, if theta lies in the first quadrant, we know sec theta and tan theta both will be positive. So the point P will be of the form plus comma plus, and that is the point will lie in the first quadrant. If theta is from say 90 degree to 180 degree, that is it lies in the second quadrant, then we know sec theta and tan theta both will be negative, and therefore the point will be of the form minus comma minus, and it will lie in the third quadrant. Now, if you want to imagine how this is happening, so let us draw a diagram and try and understand the situation here. So here say is the x-axis and here is the y-axis. So we draw a hyperbola here in this manner and say the auxiliary circle is in the following format. Now, if we take the point Q here such that it makes an angle which is greater than 90 and less than 180 degree, what we do is we draw a tangent at this particular point Q. Now, this tangent meets the x-axis at point what we call as N, and now what we do is we draw a perpendicular, and this perpendicular meets the hyperbola at a point P. Now this, my dear students, you can see lies in the third quadrant, and that is how we select the point. Now sometimes there is a confusion that a student might understand that if this is the perpendicular, this meets the hyperbola at a point which lies in the second quadrant. But this will not be our choice of selection of point because of the format that we have taken. I hope this is clear. Now similarly, if the angle is from 180 degree to 270 degree, then tan theta is positive and sec theta is negative. So the point will be in the format negative comma positive, and this will indicate that the point lies in the second quadrant. And finally, if the angle is from 270 degree to 360 degree, the point will be of the format plus comma minus. This would indicate that the point lies in the fourth quadrant. So this is how we take the points according to the value of theta. And also, my dear students, I hope you understand how do we select the parametric coordinates and what is called as the parametric equation in case of a hyperbola. And also, we must understand the circle which helps us to find the parametric equation, and that is called auxiliary circle. So that is all that we have in this video, students.